So to show incremental coding, we're going to break this process down for another example. And we're just going to do a little bit of incremental coding with this one thing. And I want to do this little problem here for palindromes. And a palindrome, we're going to check a string if it's a palindrome. And a palindrome is a word, number, phrase, or other sequence of characters which reads the same forward as backward, such as madam or race car. If you look at them forward and backward, they're the same. And that's actually a definition from Wikipedia right there. And so to do this, I'm just going to create a new file. Stick it in the right place so we'll have it for later. Call this palindrome. Give us some room here. Okay, so I want to write a method. And we're going to write a method is palindrome. So we're going to write this method. And we're going to use incremental coding to do the method. And it's going to take some data, some string, and we're just going to call it data for lack of a better word right now. But first, let's just make sure we're actually getting some string. So again, we're going to use a print statement. We're going to check to see if we're really getting the string and if we can access it. Now, think about what this is going to do. It's going to check when it's asking a question if this is a palindrome. So we can return something like return none, which really is just a placeholder or doesn't really return anything. Maybe we should instead return, how about false? We're just assuming that the thing is not a palindrome, just as a default thing. We're just saying by default, whatever you pass in is not a palindrome. Even if it is a palindrome, we're still going to return false for now, because we don't know how to check for a palindrome yet. So let's actually run this is palindrome. And let's put in one that we know is a palindrome. And so we get is palindrome, madam. Well, we print out our data and then we return false. And so it printed out there, printed out false. So, okay, we have a basic stub. We call that a stub, by the way, just not doing anything useful, but it runs. But we need to figure out how to solve this problem first. So let's actually think about how we solve a palindrome. One way, and this is just one way. There's many, many ways of doing this. We have some string. And let's say we have the string madam. And we want to convert that string to, say, a list of characters. This is just one approach. So we take that and we want to break that into a list of all the characters in the string. Because we're going to use that list. There's actually a number of ways we can use that list to confirm this is a palindrome. So how do we do that? Let's go take a look. So I have data and data LST, just make an empty one. Start with empty. And then we do, well, a for loop, right? Every character in data. And then we need to put that data in the data list. How do I put the CH into the data list? Anybody remember that one? Right, append. So data list dot append. And we're just going to append the character to the data list. And let's make sure it worked by printing out the data list. Remember, each step of the way, we just kind of check to see if it's working. And we're just going to use a lot of print statements. And when you're developing a program, print statements are your friend. They're basically, we can use indexing, but do we gain anything from indexing? We're going to go through every, remember, this is actually a string, not a list. And this is an empty list. So we're taking each string as a character and we're appending it to the list. Yes, you can index into a string, but it's actually easier not to. And just to run the same example previously, let's see if it worked. Did we get our data list? MADAM. Perfect. So we confirmed that it worked. And that's the thing. We just want to confirm that it works. All right, well, let's go back to think about our algorithm. How are we going to solve this? So now we need to figure out, how do we know this is a palindrome? Split, unfortunately, split, what are you going to split on? There's no commas, there's no delimiters in the string. And I don't know if split can be passed an empty string and split everything. I don't know if that works or not. What we did is actually, I mean, whether there's easier ways to do it, it works. So does anybody have any suggestions on how to confirm this is a palindrome? We have a list. How do we go through that list and check it? Interesting. Okay, that's a bunch of answers. Reverse method, check the first and last index. You can use methods, compare the indexes, use a method to reverse. I actually like the reversed one. I was going to do the reversed one anyway. There's actually multiple ways you can do this, as there always are. Let's say we have a reverse list. Let's think about what a reverse list would look like for a palindrome. So this M, this A, this D, this A, this M. Oh, funny. Reverse list looks like exactly the same as the original, except when we do a comparison, we'll compare this character to that character, and that character to that character, et cetera, et cetera. So we basically will just reverse through the list. We create a reverse of the list. And let's think about what would happen if, let's see, do I have any volunteers? Let's try to think of one. Let's use one of our tutors, only because that's the first name that popped in my head. So Rosie, let's see if Rosie's a palindrome. So first we break Rosie into a list. And then we create a reverse list. And then we have Y, E, S will actually not move, O, R, and then we compare R to, actually, that's not a comparison, that's removing the characters. Here's the comparison. The comparison is right here. That failed. The comparison here will be there to there, and that actually is true. There to there, true. So we basically assign them back to front, and then we compare all the way through to see if they're the same. And this one failed. So it's not a palindrome. So unfortunately, Rosie does not go down as a palindrome person. So let's think about how we code that. Again, there's a number of different ways we can write this. This is just one. The index way is actually a good way as well. But there's other ways, and you can always try to, in fact, by the way, this whole fact that we had different people come up with different ideas is actually a pretty important thing in computing courses. There is usually no real one way. For complex problems or open-ended problems like this, there's no real one way to solve the problem. And coming up with your own way is usually fine. It's just I have a specific plan for this example. And unfortunately, this is one of the things that makes finding academic integrity in computing courses actually pretty easy. If you have two students with the exact same code for some problem, the autograders that we use actually do text comparisons. Even changing the variables isn't enough. It easily detects if you have the same code in the same sequence. And so it's very rare that two students on a large and open-ended problem will have the same code. It's very, very rare. And usually it passes a certain threshold, at that point, we usually submit it to the academic integrity office and have them check. And so keep that in mind. It's actually pretty easy for us in computing classes to check to see if people have shared code when places they shouldn't have shared code. Okay, let's create the reverse list. We could make a method, but we could also just do it in this method. So we can use a reverse method to make a new list, but we can also, and then return the list. Remember, you can return this. I'm not reversing the original list. Let me rephrase that. I'm not replacing the original list. I'm making a brand new list. That's reversed. And I want to go through each and every element in the original list, this one here. But I want to traverse it in reverse order to fill this list. Yes, I could write it in a method, but I'm just going to write it directly in here because it's not very long. By the way, notice I'm starting to split my code up into sections. This is actually a good time to kind of make it more readable and to add comments to each of these sections. Comments help us read our own code and help others read our code as well. What's this first block doing? You basically want to describe the entire block. You don't want to do a line-by-line comment. You just want to know what the block is doing. This first block converts a string to a list, right? That's all it's doing, converts a string to a list. We take the string. That one string will then be processed and put into data list. The second block is going to create a reverse list, right? Same thing. We just write a block, and now I can actually make it do this thing here. Yeah, this is actually the single line comment. There's another comment, which I believe is, I'm actually not sure. I don't use it very much. I tend to just use single line comments, which is the hashtag. I think it's this. Yeah, it's this. This is a multi-line comment, which is multiple. I don't tend to use it because it's easier for me just to put a pound symbol in front of it. But regardless, you do what you want to do. Just remember, if you do a multi-line here, you better put one at the end or you lost the rest of your code. And comments are ignored by the interpreter, so it's good to put comments in your code so you can read it. All right, for loop. Now we're going to use a for loop with an index. So let's call it index in, and I want to use a range, but I need to figure out what my range is going to be. So what is going to be the arguments for range? Remember, we want to traverse this list in reverse order. How do we do that? Length. So we can take the length of the data list. Is that it? Or is there more? Length minus 1, right. The length is going to be, in Madam, is going to be 5. But remember, we don't start index 5, we start index 4. So we have to subtract 1. When do we stop? Can't stop at 0 because we want the 0 character. We stop at -1, right? Whoops, -1. And what's our step to make sure that we go backwards? Yeah, -1. -1 makes sure that we go backwards. Every step of the way, we reduce the index by 1. So we start at 4, 3, 2, 1, then 0, and then -1 in the loop ends. And then all we have to do is just append. Reverse list, dot append, and we just append the data list at this particular index. And of course, just to make sure it works, we're going to print it out. Constantly printing it out ensures that it works every step of the way. Because I may have a bug in here, and I'd rather find it now before I add a whole bunch more code. Let's see if I missed anything. Let's do Madam. All right, Madam, that worked. Let's do Rosie. YESOR. Yeah. Okay. So reverse is working. So we confirmed that it's working by using the original, palindrome, but we really confirmed it working by using a non-palindrome. So now we know it's working. And still, we're getting close, but it still prints false no matter what we do. This is a palindrome, but we have false because we're just returning false. No matter what we put in here, it's going to return false because we're telling it to. So we're not checking to see if it's a palindrome yet. We're not doing any logic. So how do we compare two lists? How do we compare them? How do we know if data list and reverse list are identical? Or how do we know that these two are not identical? Anybody have any ideas on how to compare two lists? We could use a for loop, but Python actually has an if statement and a comparison operator. We could turn them back into strings, but believe it or not, Python will actually do a comparison for us. Python, the double equals operator for Python will actually check the contents of the array or the list. So it's actually easier. There are other ways, and in Java, this wouldn't work. So when you're in 8B or 11, this isn't going to work. Then you would have to maybe do another for loop or something to do it. But Python, that's all we have to do. And we run this now, and we check for Madam, and we get a true. And we check for Henry or Rosie, and we get false. And so now it says true for Madam and false for Rosie. So it looks like it's working. Let's try another one. Let's try the race car. Oh, that was true as well. We can try more things, and we should try more things. But everything seems to be working okay. So we basically have our first version. So we should do a little bit more testing. What about a single letter? Should that work? So some edge cases, that's a strange one. But technically it is a palindrome. It reads the same forward and reverse. So it's actually a palindrome. Empty string, hopefully it doesn't break. And it doesn't, good. Well, technically, I guess it is a palindrome. Or we could maybe do something else to say no, but it's okay for us. At least it didn't break our code. So this process of building things one thing at a time, that's the process of incremental coding. We just kind of take one thing, do it, one thing, do it, over and over. So the way that works is the length of data list. If we're using Rosie, the length of the data list, which is this one here, is going to be 5. 5 minus 1 gives us 4. So at the moment we're calling range with 4 minus 1 minus 1. So that's what the range is going to look like. So we start at 4. If we map this out, so index, we're starting at 4. Data list, which I chopped it off, but it's right there. And same with red list. Data list at index. And let's actually look at every iteration. Let's look at what the rev list has in it. Initially, the rev list has nothing in it. Data list currently at index. Current index is 4. Data list at 4 is the Y in Rosie. And then we decrement by 1. So we go to 3. The data list at 3, index 3 is 0. However, I forgot to step. Before we go to 3, we have to run the body. And so we append the Y to the rev list. So now in this iteration, we have a Y only. O is right here, and so we append that. And instead of actually doing this over and over again, I'm just going to keep 1. At index 2, because we subtract 1, what is index 2? Well, it's the S in Rosie. We append that to the rev list. Subtract 1 because we're decrementing. That's the E in Rosie. Sorry, not the E. Did I get it backwards? Oh, I skipped the O. I reversed these two, by the way. The E, I did it again, didn't I? 3 was E. I did it backwards. 1 is O. So actually the E went right there. Now we append the O. Index 0, we keep going because we're not done. That's the R, the beginning of Rosie. We append the R. Then we go to -1. We now hit the endpoint. Remember, we don't include the endpoint, and we stop. And so our final reverse list is this, which is the same as that. So that's all we're doing with reversing the going backwards inside of the range. So incremental coding, go through small piece at a time, get the next thing working, get the next thing working, get the next thing working. Any questions? Any more questions about how this works? I mean, this is just one way of doing things. And we're going to run out of, well, I'll keep going. Let's actually look at the next process. So iterative development. So imagine that you wrote that program and it works for strings, but someone asked you to say, well, can I put something else in there, right? What about more than I want a word, I want to work for a word, a number, a phrase, or any other sequence of characters, right? They could be palindromes. So what if your friend or maybe your teacher said, okay, now I want this to work for integers. And so let's run it and let's try 1, 2, 3. Sorry, 1, 2, 1. 1, 2, 1 is technically a palindrome, right? Technically, that's a palindrome. But if we run it, we get an error. And it's telling us that int object is not iterable. Since the int object is not iterable, let's look, say, line 6. Right here, which also printed int. Where did I get an int? Data. Oh, data is an integer right now. We printed out 121. We passed in an integer, not a string. Well, that's a problem. You can't iterate through an integer. So we figured out what our problem is. We looked at it and we said, well, you cannot iterate through an integer. It doesn't work because whatever comes after in has to be a sequence, like a string is a sequence of characters, or a list is a sequence of things stored in a particular order. But an integer is a single thing, not a sequence. We can't go through the integer 1, 2, 1. So it's saying we have this as an error and it gives us this int object not iterable. So how do we fix this? I mean, one way is to say, well, I refuse to handle integers and you must pass it as a string. However, that doesn't really, I mean, it works, but that's not what we want. The other person is saying, no, it really needs to work for integers. So we need to look at our code to fix this. So we go through the debugging process, which we're already doing because we figured out what the problem was. But now we're going to go through and try to fix this. And so one way is to just take the data, convert it to a string, and pass it directly back, right? Just use the same variable. It's not a good idea, though, to modify your parameters. So instead, let's actually print out or create a new string and then print it out. It's not a good idea to modify your parameters. There's really very little reason why you should, and it's confusing. But now we have to turn this into a string, and I think that's the only place we should look. It's the only place it's being used. So this thing that we're doing right now is called iterative development. We took one version of code that worked for strings, but now we're iterating over it to make it work for integers. It should also technically work for floating point numbers because we're just casting it to a string, type conversion to a string. But we're not using, yeah, that's it. It looks like we got everything. Let's actually run it and see. Look at that. That is a palindrome. What about 1 2 1 1 2 1? Technically, it's a palindrome. Or 1 2 3 3 2 1. True, also a palindrome. You included the dot. Remember, the dot even got turned into a character. So in the list of strings, it's actually in there as well. It's being checked. So once you figure out if your program is working, by the way, you should make sure to remove all these print statements. I'm just going to comment them out, but you should delete them. Because when you turn things in, we don't want those print statements in there. If you turn something into Gradescope and you have those print statements in there, you might break the auto grader. Race car. Where's Rosie? Oops, there's Madam. There. We just want the answer. We don't want all that stuff printed out. We only use the print statements to help us debug and test our program. And then when we're done, we just get rid of it. And we could also do, we can check something else too. How about San Diego? Is that a palindrome? No, it's not. So first we did incremental coding, and then we went and did some iterative development by modifying existing code with new, because we wanted to handle new rules, right? We were told, hey, extend the program to work with integers and floating point numbers. We extended it. We made a new version that worked.